بسم الله الرحمن الرحيم. اليوم راح نرجع نكفي بالشابتر نمبر 4. بنكفي بالاديشن والسبتراكشن، راح نحكي عن الساين and magnitude. خلينا نبدأ بالساين and magnitude integers. بهالحالة أنا عندي 4 case. في عندي I have 4 different combinations، يا addition يا subtraction يا multiplication يا division. بس بما إنه ولكل حالة أنا عندي يا بتكون positive أو بتكون negative، يعني لكل حالة أنا عندي خيارين. بهالحالة آخر شي بيطلع عندي ب 8 possible cases that I can talk about them. 8 possible cases. بس بما إنه نحن قبل ما حكيناش عن ال multiplication وال division، فكمان مش عم نحكي عنها، أو هاي الشابتر أو الجامعة ما بديش تفصلهم بهذا الشابتر. So now I have this this is the steps that I can do them to add and subtract. Let's say I have r which is equal a plus b or a minus b، لأنه لما مش راح نحكي عن division وعن multiplication، فبنبدأ بس بالaddition والsubtraction. فرضا أنا أعطيته للبرنامج ال a plus b أو a minus b، فهو هون بيجي بيعمل لي تشيك في حال كان بوزيتيف أو كان addition فبينتقل لهون دايركت. في حال كان نيجاتيف بيعمل فليب، هاي معناتها هاي اللي هون معناتها فليب، يعني إذا إلا الساين. نتذكر بس الماجنتيود sign and magnitude format. let's say I have 4 bits. هذا البت آخر بت هي بتكون بتدل على الساين، يعني بهالحالة هي نيجاتيف. طيب أنا بعملها فليب، ف let's say I have to subtract 1101 minus 1101، فبعمل flip للB which is this one, it will be 0. after that بعمل flip كما بالبرنامج هون، بعمل XOR بين الساين تبع ال A والساين تبع ال B. في حال كانت 1 بروح على الستيب، في حال كانت الXOR عطاني نتيجة 0 بروح لهون. طيب أنا هذه فصلتهم بستبس، خلينا نشوفهم هون. في حال كان addition أول ستيب بعمل XOR للساينز، بعمل XOR للساينز. إذا طلع عندي ال XOR أو XOR طلع عندي 1، فبرجع لهاي الستيب اللي هي بعمل 2's complement for B. بعمل 2's complement لل B وبرجع بعمل add لل A وال B. إذا ما طلع عندي overflow بعمل 2's complement لل R اللي هي A plus B، ال B اللي هي 2's complement. يعني أول شي بعملها 2's complement، برجع بجمعها مع ال B مع ال A بحطها بال R، برجع إذا ما طلع عندي في overflow بحط الساين بالبي. الساين للR بيكون هو الساين للبي. طيب في حال طلع عندي صفر أو الS طلعت صفر، فبهالحالة أنا بروح على هالستيب دغري دايركتلي بجمع ال A مع ال B. فإذا طلع عندي overflow بعمل stop، وهون في حالة طلع عندي overflow بعمل stop. بينما هون بنكمل إذا ما طلع overflow، if I don't have overflow بالR هي الجواب، وحط الساين لل A. إذا كانت ال A positive بحطها positive، إذا كانت ال A negative بحطها negative. طيب في حال كان subtraction أول step برجع بعمل flip للساين. أول step بعمل flip للساين وبرجع بكمل بنفس الستبس تبعت الاديشن. يعني أول شيء بعمل flip للساين، برجع repeat the addition step. يعني هول الستب اللي عملتهم هون بعملهم هون. إذا طلع بعمل XOR للساينز، إذا طلع ال S 1 بعمل 2's complement لل B برجع أجمعها مع ال A. إذا طلع ال S 0 بعمل 2's بس بجمعها جمع عادي، وهاي بكون خلصت الستبس. طيب examples. طبعا أنا حطيت هون 4 examples موجود بهالسلايد. example حطوا الدكتور، فخلينا نجرب نحن نحل الاكزامبلز اللي أنا حطيتهم أو نحل واحد منهم. بهالحالة addition يعني ما في داعي أعمل flip للساين تبع البي، دوري بعمل XOR. طيب عندي أنا هوني هذا البن، عندي هوني XOR للزيرو مع ال1. الإكزور لزيرو مع ال1 بما إنه different فبيطلع 1. so s equal 1. بهالحالة أنا بروح على هالستep. فثاني خطوة بدي أعمل توز كومبلمنت للبي. طبعا أنا بنسى هالوحدة اللي هون وبنسى هاي الصفر لأنه هذه للماجنتيود هو للساين. فبعمل توز كومبلمنت للبي. توز كومبلمنت للبي ببدأ الصفر بنزل الواحد مثل ما هي، ببدأ بعمل فليب 0 1 0 1 1. طيب ثاني شغلة، ثاني خطوة بعمل اد مع الاي. اد مع الاي اللي هي 1 0 0 0 1 0 0 وبجمعهم. طيب 0 مع 1 0 plus 1 it's 1 1 0 1 1 1 1. فأنا طلعت الجواب. طيب هسه بدي أحط الساين. حطينا الساين برجع بعمل له flip أو بعمل له two's complement. so I will do two's complement again for this 1 0. نزلت أول واحد فببدأ بعمل flip 0 0 0 0 0. هذا الجواب تبعي. طيب شو الساين تبعه؟ هو the same of the sign of the B. الساين تبع البي كانت عندي 1 فبيكون الساين هو 1. those are the steps. فبزيد أنا واحد لهم. طيب خلينا نتأكد من الجواب تبعنا. هذه إذا جينا نعملها فمعناتها 17 1 plus I don't need 2, I don't need 4, I don't need 8, I need 16. So it's plus 16 plus I open bracket because I have negative here. Negative كمان 16 plus 4 20 plus 1 25 22 sorry 22. 16 plus 22 equal minus 5. والجواب اللي طلع أنا عندي هون بما إنه هاي minus بما إنه هاي 1 1 plus 4 5 كمان. هذا الجواب. ونفس الخطوات بعيدهم على هاي الحالة. هسه بنرجع نعيدها بس مشان يطلع الاس 0 والباقي يكون سهل إن شاء الله. In this case I have plus again. So no need to flip. Just start by XOR the sign of this with the sign of this. فبيعطيني XOR 1 مع 1 equal 0 لأنه the same 0. فبهالحالة أنا بروح على هذا الخط. بعد ما اروح على الخط just add A مع A الماجنتيود تبع ال A مع الماجنتيود تبع ال M. I forgot about this and I forgot about this and all these signs. فبدي خلينا نكتبهم 0 1 1 0 1 0 0. This is the B. So now I will add the A 0 0 1 0 0 0 1. نجمعهم 1 1 1 0 1 plus 1. Here I have 0 carry 1. Now I have 1 here 0. Okay, in which case I know that I have overflow if I have the last digit 1 here, the last digit 1 1. So the answer is 0 and the remainder 1. So in this case I have a carry. But in this example I don't have any carry. So let's check our answers. Now continue. والساين تبعها بتكون the same of sign of B sign of S sorry sign of S فاللي هي of A which is 1. So 1. Again the answer is negative. Let's check. Here it's negative 17. This example is negative 17 plus negative 22. The answer is negative 39. Let's check. 1 plus 2 plus 4 8 I don't need it. 16 I don't plus 32. So the answer is, this is for the sign negative 39. So my work is done correctly. Now I will move to the other example. This example here, sorry, it's negative, it's subtraction. So in this example, I will do the subtraction. 1 here and 1 here, and I have subtraction. So here it's negative 17 again, minus 22. الجواب مفروض يكون 5 plus 5. So let's start. It's subtraction. I have to flip the sign of the p, which is 1, it will be 0. Now 1 XOR this one with this 0, I will get 1 because they are different, so the answer is 1. In this case, I have to move in this way. Now I have to flip the p. Let's flip it, or 2's complement, sorry. It will be 0, 1. Now I start to flip 0, 1, 0, 1, 1, and this one I will forgot about it, so forgot about here. What I wrote here. Eraser, I will erase this. Now let's continue. And I will copy the 1, 1, 0, 0, 0, 1, 0, 0. Let's add them. 1, 1, 0, 1, 1, 1, 1. I got this one. Now I don't have any overflow, so I have to flip it or to take the 2's complement again. So this will be 1, 0, 1, 0, 0, 0, 0. Sign تبعها بتكون same of sign of the B, which is I flip it before. Here it's negative. It will be it was 1. I flip it, it becomes 0. So the sign is 0. My question is, or my answer is plus 5. So my work is correctly done. Now he gave us an example. I solved it before with you. Here it's plus 17 plus minus 22. The first example that we solved it. After we flip it here, we got negative 5 because the sign is 1. Here is another example. They are adding minus 81 minus 22. So first step, the operation is subtracting. So I have to subtract. Then I have to flip this. It was 1. It will be 0. So now I XOR this one with this one. I will get 1. So I have to move in this way because my answer is 1. So the first step, I have to get the 2's complement of this. 2's complement 0, 1, 0, 1, 0, 0, 0, 1, 1. This is 1. Here 1, 1, 0, 0. I forgot about this because this is the sign, because I'm talking about sign and magnitude format. Now after that I have to add it. I have to add it with this. So he copied it in this way and he added 1, 0, 1, 0, 1, 1, 1. Now I have 1 plus 1. In this case I have a carry. You can see the carry. 1 plus 1 is 0 and carry on. So I have overflow. I will take the sign and that's it. Now we will talk about arithmetic operation of reals. Arithmetic operations of reals. In this case, I have more steps, or I have another steps. I have to talk about them. It's more complicated than sign and magnitude. So our arithmetic operation such as addition and subtraction, multiplication and division, we will not talk about multiplication, we will not talk about division, can be applied to reals, because I can apply any arithmetic operation for the numbers. I can apply it for the integers, I can apply it for reals, I can apply it 4 decimals. Multiplication of two reals involves multiplication of two integers. Representation. Okay, since we did not discuss the multiplication and division, so we will not talk about them again. Only we will show addition and subtraction for reals. Let's start. Addition and subtraction for reals stored in a floating point numbers is reduced to addition and subtraction of two integers. So I have the first step. I have to align the decimal, because if I want to add 2.25 plus 1.25, I have to make sure that the decimals are on the same level, same as floating. If I'm adding 110.101, I have to add the other number. I have to make sure that the float or the decimal is in the same level. This is the step that will be a little bit complicated. So let's talk about the steps. First of all, we will start from here. If I have addition, if I have subtraction. If I have addition, a plus b, so I forgot about this step. If I have subtraction, again, I have to flip the sign. You know that the numbers here, I have sign and floating point. I have three parts: sign, exponent, and mantissa. So let's go back here. After that, I will denormalize. Let's say I have, when I normalize, I remove the 1. If I have 1.0111, I normalize it, I remove this one, and I remove the decimal. So it will be 10111. So when we denormalized, mean you have to add this one and you have to add the decimal. This is the point, or this is the, so I have to add this one. This is the point of denormalization. Then I will compare between the exponent. If they are the same, the exponent, I can move to this step. If they are different, I have to move to this step. First, I increment. I will add 1 to the smallest exponent. I will add them to it, and shift right the mantissa. Let's say I have this one and I'm shifting it to right. It will be 0 1 0 1 1 1, and because I have zeros here in the mantissa till I have 23 digits, I will lose one of them. Then I will compare it again. If the exponents are equal, I can move to this step. If they are not equal, I have to increment it again. Increment and increment, so on. So I wrote those steps in this way. First of all, we have to denormalize and increment the exponent. This is the first step. Denormalize and increment. Second step, I will compare between the exponent. If they are different, shift right the mantissa, increment the exponent. The least one, increment the least exponent. Then I will compare between them till I get equal exponent. You will see the example and you will understand what I'm talking about. After they are equal, I can add the mantissa. When I found equal exponent, I can add the mantissa. If overflow happened, here in this case I have overflow. Let's go back to this one. If I have overflow, shift right the mantissa and increment the exponent again. Shift right the mantissa, increment the exponent, then again normalize. Those are the steps. Here they are giving us an example. This is the first one. I'm adding 5.75 plus 161.875. The answer is this, but let's check it when we have floating points or binary numbers. First of all, do you remember in chapter 3 how to store a floating point in format? I have three things: sign, and the magnitude, the exponent and the magnitude. Now here the those are the numbers that I have, 5 point and 161 point. First step, I have to, let's remember, I have to denormalize and increment the exponent. So I have to add one here and one here, and I have to add one for this number. It will be, and one for this number. I will show you. This is will be 1 1 1 4 zeros 1, and this will be 1 plus 1 is 0. I will write it here, 0, and carry 1. Now 0 plus 1 is 1, 0 0. So this example is written here. So after denormalized, this is the one that I added it, and this is the other one. This is when I increment the exponent, and here I increment it. So I compare between them, but I found that this exponent is less than this exponent, or they are different. So I have to increment this exponent 1 and shift right, increment shift right, increment shift right, till I have equal exponent. Here, this is the exponent that I will get it. Okay, let's increment it step by step. It will be a little bit more clear. So add 1 for this. It will be 1 0 0 0 5 zeros 1 1, and I shift right this one, shift it to the right. So I will lose this one, and I will have 0 here. So then I compare between them. They are different. So I add 1 again. Add 1. It will be 1 0 0. This is mean 4 zeros 1 0 0. After I add 1 for it, plus 1. So now I shift right this. It will be like this, 0 0 1 0 1 1 1. Now I have the exponent are till now they are not equal. So I increment it again by 1. It will be 1 0 0 0 0 1 0 1. Till now they are different. I again shift right. After increment, shift right. Then I compare. They are different. So again I increment it. It will be 1 0 0 0 4 zeros 1 0 1. Now sorry, here it's not, it will be 1 0 1 0. Now after that I found I shift right, so I will add 1 0. Now again they are not equal, so increment, it will be 1 0 0 0 0 1 1 1. They are equal. I just shift right here, and this is the step. So I got 5 zeros 1 0 1 1 1, and so on. I will write it again. I will write those again, but I will erase the incremented steps. I do those steps till I get equal exponent. So this will be 5 zeros 1 2 3 4 5, and then 1 0 1 1 1, and the rest are zeros. I will not write them. So now I add this step. I have equal exponent. I add them. So I will align them here. It's 1 0 0 1. Sorry, this is 1, and here I have 4 zeros 1 2 3 4 1 1 1 and 4 ones. So I have above this I have 1 0. After that you can add 0 plus 1 1, 1 plus 1 is 0. I have carry 1. Now 1 plus 1 plus 1 is 1 and carry 1. Again 1, carry 1. Now 1 1 0 0 1 0 1. So I have this number. It's written over here. This is the number that I got it. Now we do sign and magnitude addition. This is what we did. Sign and magnitude addition. Okay, there is no overflow. Again, we'll go back. I got the last step is was 0 plus 1 is 1. No carry, so no overflow. Now, so just normalize. If I got overflow, I have to shift. If I got overflow, I have to shift the mantissa right and increment the exponent. But I didn't get anything, so that's what we are talking about it. Go back to this one. There is no overflow in the mantissa, so we normalize. We remove this one in normalization and subtract, or let's say remove this and decrement 1. We decrement 1. The mantissa is only 23 bit, no rounding. If I got more than 23 bit or 24 bit, so I have to round. E is, this is the exponent, 134. M is like this. In the other word, the result is, that's it. And again, I'll send for you some worksheet. If you need, just talk to me via WhatsApp. Thank you. Assalamu alaikum.